Solve by completing the square. We have 3m squared minus 6m equals 5, and we need our lead coefficient to be a 1, so I'm going to divide all three terms by positive 3 so that we create a 1m squared. So dividing out, we have 1m squared. Negative 6m over 3 is a negative 2m. Going to leave a space, and that is equal to 5/3. And now we'll take care of the completing the square part of the problem. We'll take negative 2, cut that in half, we get negative 1, and when we square that, we get positive 1. So we're going to add 1 to both sides of this equation. On the left-hand side, we've created a perfect square trinomial. It's the quantity m minus 1, the quantity squared, and that is equal to 5/3 plus 1 we can think of as being 3/3. 5/3 plus 3/3, or 1, is 8/3. Now we'll go ahead and take the square root of both sides. Taking the square root of the left gives us m minus 1. Taking the square root of the right hand side gives us plus or minus the square root of 8/3. And now we'll use the quotient property on the right hand side. On the left we still have m minus 1 equal to plus or minus. The square root of 8/3 we will think of as being plus or minus the square root of 8 over the square root of 3. And the square root of 8 becomes 2 root 2, and we have that over the square root of 3. And now we need to rationalize the denominator, so we'll multiply top and bottom by the square root of 3. So simplifying what we have m minus 1 equals plus or minus 2 root 2 times root 3 is 2 root 6, and denominator root 3 times root 3 is 3. So currently we have m minus 1 equals plus or minus 2 root 6 over 3. We'll go ahead and add 1 to both sides. So we have m equals 1 plus or minus 2 root 6 over 3. That is a correct answer. Most textbooks would like you to write your final answer as one fraction with a common denominator. 1 is the same as 3/3, so we can combine those together. Again, 1 is the same as 3/3, so we would have 3 plus or minus 2 root 6 all over 3. So there is the final answer to this problem. M is equal to 3 plus or minus 2 root 6 all over 3.